In this video, we're going to continue going through some more circle theorems, and today we're going to focus on tangents of circles. It'll be helpful if you have the worksheet nearby, whether that's printed, or if you don't want to print it, you can just have it on the computer near you and then just write it in your book. But we're going to go through the examples as well as some key points at the start. You're first probably thinking, like, what is a tangent anyways? Well, a tangent is just a straight line that touches a circle at exactly one point. You can see that in the diagram. The radius tangent theorem says that the angle between a tangent and the radius is always 90 degrees. The other theorem we're going to look at in this video is the two tangents theorem. It just means if two tangents are drawn to a circle from the exact same point, that their lengths are the exact same. All right, let's start looking at example 1 then. So example 1, we've got a circle centered at O, and we want to work out the size of each angle marked with a letter. So that's B and C, and we want to give a reason for each step. So first we can say, well, it is a triangle, and we've got one angle is 56 degrees. Hopefully you noticed that B is going to be 90 degrees, and this is because if there's a tangent, we know it's a tangent because it only touches the circle at one point, and that has to be perpendicular to the radius, so B must be 90 degrees. Then we know that triangles always add up to 180 degrees, so we can find out that C is just 34 degrees. In example 2, we're now given another circle where again it's centered at O. Then we're actually told that angle E, the angle outside of the circle, is going to be 30 degrees. We want to figure out what the angles D and C measure, and we're going to give reasons for each one. So first, E is just 30, it's given. Next, we actually need to figure out what the angle RQO is in order to help us figure out what D is. And now remember that RQ is going to be a tangent to the circle, so that angle must be 90 degrees. Then we can say, well, that's forming a triangle, so we'll add up 90 and 30, take that away from 180, and get D is 60. Lastly, you should see that D and C are in a straight line, and straight lines always add to 180 degrees. So to find out C, you'll do 180, take away the 60 for D, and you get 120 degrees for C. In this next example, we've got a circle that's centered at O, and we're told the angle A, which is inside the circle, is 125 degrees. We want to work out the size of angle B. So first of all, we're told one angle, but we actually know three angles right now. We've got two tangents, so at R and P, we must have 90 degrees. Now to find B, you have to recognize that we're not going to be using a triangle, but actually O, R, Q, and P form a quadrilateral. Quadrilaterals have 360 degrees. So you'll add up the three that we know, take them away from 360, and we'll get that B is 55 degrees. We're on to our last example now. So we've got a circle with center O. We've got the angle outside, ATB, is 34 degrees, and we're trying to figure out ABO. So you should notice that that's one of the angles inside the smaller triangle. It's not the full 90 degrees. To do this, we actually have to first find angle AOB, the larger one inside that triangle, and we can use that to find the other angles because it's an isosceles triangle. So first, there's a 360 degrees in the quadrilateral, so we'll take away the 34, 90, and 90 from the 360 to get that AOB is 146. As I said earlier, we're now looking at triangle AOB, which is an isosceles triangle. If we want to figure out the base angles, we have to remember that they're going to be equal, so we can just do 180, take away the 146, we get 34, and then you're going to divide it by 2 to get just one of the base angles. So angle ABO is 17. That's all for this video. Now you can go ahead and finish the worksheet. Again, you can do this whether it's on the actual worksheet or just in your maths book. If you have any questions, then post a comment on Show My Homework, and I will get back to you. Thanks.